Hello, good afternoon, good evening, good morning, wherever you are in the world. Thank you so much for joining us today for this Hemingway Award Talk 2021. Thank you for sparing the time. This webinar is hosted jointly by the Royal Society of Tropical Medicine and Hygiene and by the Liverpool School of Tropical Medicine, who jointly fund and provide the Hemingway Award. And I'll tell you a bit more about the award in a couple of minutes. Just to introduce myself, I'm Tamar Ghosh. I'm the Chief Exec of the Royal Society of Tropical Medicine and Hygiene, and I'm here representing both RSTMH and LSTM to welcome you to this wonderful occasion. So today we have an incredible talk by the winner of the 2021 Hemingway Award, Dr. Maria Eugenia Grillet, on the topic of vector-borne infections in Venezuela. We're so happy that she could be here to join us today, and you'll be hearing her talk very shortly. Before that, just a little bit about RSTMH and LSTM. So RSTMH, for those of you that don't know, we're a charity, we're a membership society for people working in tropical medicine and global health. Our aim, much like LSTM's and many other organizations in our field of work in our community, is to eradicate disease, is to improve equity, and is to make access to health fairer for all. Now, we were established in 1907, so we're quite an old society, but we're brought up to the modern times. Our impact, we hope, is to support our members in their careers by providing them with funding, with opportunities to showcase their work, to publish their work, to increase their networks, to increase their skills and their experience. And alongside supporting our members, we also try and make some big differences against those targets I mentioned by identifying areas of health that we need to showcase, raise awareness of and champion. We also identify funding gaps and research gaps, and we try and plug them ourselves or through our network of partners and supporters around the world. Now, we're a small team of 8 people based in London, but we have 1,000 volunteers that support us in various aspects of our work as ambassadors, as board members, as committee members, and keeping our journals moving as well. And day to day, we run our 2 scientific journals. We have meetings and events like this online, but also ones more face-to-face as time is going on. And we also give out early career grants every year. And we're lucky to be able to celebrate the success and the enormous achievements in our sector through our medals and awards. And this Hemingway Award is one of those examples. So I'm so pleased that you're here to listen to our 2021 awardee. So a bit about LSTM. It was established in 1898 as the first institution of its kind in the world. LSTM is 125 years old in 2023, and I'm sure you'll hear lots about the incredible work they do and what they'll be doing in the lead up to that big anniversary year, and have a chance to get involved. And in essence, their work is across the world to break the cycle of poor health and poverty and to create healthy futures. So as you can tell, we have a lot in common. We've been partners for many years, and we decided in 2018 to try and formalize that through the creation of a new award, the Hemingway Award. And this was done to really celebrate the success of the director at the time, Professor Janet Hemingway, who was stepping down from the role, had been just so successful in the field of translational science that we wanted to create an award together that really recognized and celebrated translational science. So the Hemingway Award was born. We give it out every 2 years. And it's a way of celebrating success in that same area. And I'm delighted, as I say, to have our talk today. A tiny bit of housekeeping before I get started and introduce you to our first speaker. We have around about half an hour. First of all, we'll hear from Professor Alicia Ponte-Sucre, who was the nominator for our winner. She'll tell you a bit about why she nominated Dr. Maria Eugenia, and then we'll hear from herself for 25 minutes. There'll then be chance for Q&A, so please do get your questions together. You can post them in the Q&A during the talk, and this is a great opportunity to ask Dr. Maria Eugenia anything about her topic, so please do make the most of that opportunity. Just to say, we've been very careful in pre-recording the talks from Professor Alicia and from Dr. Maria Eugenia to make sure that we weren't hindered today by any technical issues. So you will be looking at some pre-recorded videos of their talks, but as you can see, they're with us today and we'll be doing obviously the Q&A live. But just to say, those recordings are a little bit on the quiet side in volume, or for me certainly. So if that's the same for you once we start those, please do turn your volume up and enjoy those two talks. Okay, well, that's all for me. I just wanted then to pass over and welcome Professor Alicia Ponte-Sucre, who nominated Dr. Maria Eugenia for this award. And you'll be able to hear from her about exactly why she did that. So sit back and enjoy, and I'll be back at the end. Thank you again to all of you for joining today.
Good afternoon to everybody, and thanks to the Royal Society of Tropical Medicine and Hygiene and to the Liverpool School of Tropical Medicine for allowing me to share the following. In October 7, 2021, we received very great news that Professor Maria Eugenia Grillet have won the Hemingway Award. Today, I want to share with you who is Maria Eugenia Grillet. Maria Eugenia has been able to combine the concepts of ecology and spatial epidemiology to address problems affecting public health affairs, both in Venezuela and the Latin American region. Her vision has been understanding the challenge of disease infections through pathogen-vector-environment interaction that allows her to produce scientific knowledge that can be translated into strategies for control and surveillance of diseases that severely impact region. Her research focuses on the following: understanding how parasite-host interactions shape epidemiological patterns at larger scales using human Onchocerciasis as a study system, how climatic, environmental, and sociological factors drive of mosquito-borne infectious diseases in the Neotropical region, using the malaria and arboviruses as a study system. And her research has been developed within the framework of the population dynamics and landscape epidemiology of infectious diseases, using multidisciplinary approaches involving field and laboratory-based studies, as well as theoretical and spatial modeling. The impact of her work can be summarized as follows. Maria Eugenia has been able to develop and propose guidelines, strategies, and solutions to reduce the impact of infectious diseases, both at local and regional scale. Her studies have contributed to set the main strategies used for the elimination of the Onchocerciasis in the Americas through the use of mass administration of ivermectin, and her view about the critical relevance of spatial scale and heterogeneity of mosquito-borne transmission has helped to stress the importance of hotspot targeted surveillance and control of malaria and arboviruses in Venezuela. This means that she has gone from basic science to public health, meaning that she has done translational science. And she has worked both at international and national expert committees that are summarized in this slide for the design and implementation of surveillance and control methodologies for vector-borne infectious diseases. We call her MADO, and her aims thus have been understanding local ecological mechanisms and processes regulating insect population pathogens, interactions, and determining the ecological interaction and epidemiological patterns observed at spatial and temporal scales. Her production is solid and widely recognized. Her findings have contributed to understand how and why a stable pathogen-host relationship exists, and to elucidate how to disrupt these interactions to minimize disease impact, Her tenacity and dedication in producing translational science, despite difficulties imposed by the environment and general crisis that we have in Venezuela, is encouraging. Notwithstanding, she has advanced her research and has maintained high quality collaborations with Venezuelan and foreign scientists, resulting in fruitful contributions in a win-win relationship. I was thus very proud to postulate Maria Eugenia and full of pride that she has won the Hemingway Award, given by the Royal Society of Tropical Medicine and Hygiene and the Liverpool School of Tropical Medicine. Congratulations to Maria Eugenia, and let's hear her talk. Many thanks to all of you.
Good evening and good morning to all. Thanks for attending today to this talk. Before I start, I would like to thank to the Royal Society of Tropical Medicine and Hygiene and the Liverpool School of Tropical Medicine for selecting me as a recipient of the Hemingway Award 2021. I am honored, grateful, and very happy to be here to give a talk about the research I have carried out during the last year on vector-borne infection diseases in Venezuela. I want also to thank to the Professor Alicia Ponte-Sucre and the Academy of Science in Venezuela for supporting me as a candidate for this award. This talk is structured in 3 sections. In the first one, we will see how the interaction between the parasite and the vector determines the epidemiological patterns that we observe in south of Venezuela with the Onchocerciasis, and how this knowledge is important to predict the impact of the strategy of elimination of this disease in the country. Then we will learn what are the main associated factors to the reemergence of malaria in Venezuela. And finally, I will call your attention about how the Venezuela health crisis has impacted the vector-borne infection diseases, placing Venezuela as the spotlight of malaria in the region and one of the countries currently reporting yellow fever outbreaks in the Americas. Human onchocerciasis is a parasitic infection disease transmitted by the bite of black flies of the genus Simulium. This disease is mainly prevalent in Africa, but has been as well prevalent in several regions of Latin America, until very recently, when it has been progressively eliminated in most of the region. Currently, there is only one last endemic area located in the Amazon rainforest region in southern Venezuela and northern Brazil. The main population affected by the onchocerciasis in Venezuela are the Yanomami people. They are mostly semi-nomadic and live in the middle of the Amazon jungle, and due to their scant clothing, they are continuously exposed to the bites of black flies. We have found that human behavior and human immune response partially determine the prevalence and intensity of the disease in this endemic area. 2 questions have mainly guided our research with this disease. How the Onchocerca-Simulium interaction shape the population dynamics and the epidemiological patterns of the disease at larger scale, and how stable is this interaction in the local vector species, and what are the implications for disease control. The emphasis with the parasite-vector interaction is because with the Onchocerciasis we can describe Onchocerca-Simulium Complex. This is a close association between parasites and vector that has gradually developed into geographically and locally well-adapted Onchocerca-Simulium complexes in which parasites are better able to infect their local host populations. Across all the endemic areas of this disease, there are several species involved in the transmission of this parasite, and local adaptation most likely explains the focal geographical distribution of Onchocerciasis in the Americas, where the parasite was probably imported from Africa some centuries ago. Our studies, mostly based on natural and experimental infections, have identified that 3 species play an important role in the transmission of Onchocerca volvulus in Venezuela. Based on their efficiency in being able to become infected or not with the parasite after taking a blood meal, we can classify the 3 species into 2 groups. The first group is made up of 2 species that have a morphological structure here called cybarial and mature that makes them less efficient at becoming infected, and this is the case of Simulium incrustatum and Simulium oyapokense in the bottom of the slide. And another group that is more efficient as a vector because it does not have this structure, and it's the case of Simulium yanense, the main vector in this region. Here it's important to start saying that blood flies often form species complexes. In the case of Simulium yanense, this is a complex of several species, 13 described so far, but just 1 is associated with the transmission of Onchocerca volvulus in the south of Venezuela and north of Brazil. Blackfly also breed in lotic ecosystems. These are rivers, waterfalls, and streams. Therefore, the spatial distribution of this aquatic habitat should be a factor to consider when we are describing the main risk factor of this disease in a region. In relation to this species, here we can see pictures of the main breeding habitats of Simulium yanense in the south of Venezuela. We have found that the females breed or use particular sections of the big rivers and a specific substrate to oviposit the eggs. Therefore, the ecology of immature is very important for accounting for the spatial epidemiology of Onchocerciasis in this region. Landscape in a certain way is also a factor of risk of this disease in the area. Here we show the geographical pattern of the distribution of the prevalence and intensity of the disease in the endemic in the south of Venezuela. As you can see, there is a particular epidemiological stratification of the communities in the area, with most of the hyperendemic communities here represented in red, localized in the highlands areas of the focus, while the hypoendemic communities here represented in green, localized in the lowland of this region. The 2 pictures on the right are an example of the kind of landscape in each case. As a summary, the ecology of each species determines the spatial and geographical distribution in the area, but its vectorial capacity or biting behavior and its vector competence influences the distribution of the disease at larger scale. and in that way, the ecology, the vector competence, and the vectorial capacity are determining the epidemiology of Onchocerciasis in this endemic area. In the Americas, the strategy of elimination of Onchocerciasis is based on the use of ivermectin as a transmission blocking strategy. The feasibility of getting this goal and the velocity to reach it will depend on the particular species present in the area targeted for elimination. I will try to illustrate that idea in this slide. Here we have the effective reproduction ratio of the disease as a function of the level of parasite in the skin and how the breakpoint of transmission can be different according to the vector species involved. In this case, the blue line is a species with a low efficiency to transmit the disease, and the red one is a species very efficient to transmit the disease. So the contribution to transmission of low vector competent species will decrease faster than the species more efficient as a vector. In other words, the more efficient a vector is, the more difficult it is to achieve the local elimination. And this is exactly what we have found so far. In 2016, we reported the evidence of suppression of the transmission of Onchocerciasis in the focus. We show here that around 70 to 75% of the area in blue in the map are under suppression of the transmission, and these areas are where the main biting species are Simulium oyapokensi and Simulium incrustatum, while the red areas is where the transmission is still ongoing, and these are areas where Simulium guinense is the main biting species. The graph in the upper right is just to show you the high intensity of the transmission of this disease previous to the administration of ivermectin. We are talking about an R0 of around 5.3 and very high annual transmission potential. A person in a year could receive around 20 infected larvae of Onchocerca volvulus. As a conclusion of this first part, our findings have offered insight into the role and stability of Onchocerca volvulus infection and Simulium vector species and the implication for Onchocerciasis transmission and control. The elimination of this disease in the Americas and in Venezuela is a story of success thanks to the combination of basic science and public health. Now let's talk about malaria. When we plot the time series of malaria in Venezuela in the last 26 years and decompose his main components, what we observe is two strong and sound patterns, a positive trend and a periodicity beyond the expected seasonal or annual variation in cases. We are going to understand first this last periodicity by addressing how the malaria variation has responded to the long-term climate variation in all these years, since previous studies have detected a 5-year periodicity in the incidence of this disease in the country. Here we show the result of a local time series analysis. The important thing here is that we detected significant multi-annual cycle of 3 to 6 year periods, and this means that each 3 to 6 years we have a natural cycle of malaria in the country. The question now is, what is the reason of that? When we associate the time series of malaria with the time series of El Niño in the region, we found a significant association, meaning that the long-term periodicity of malaria is the result of the periodicity of El Niño Southem Oscillation. And also we found that malaria cases are intensified 1 year after an event of El Niño. How ENSO drives the long-term periodicity of malaria? Rainfall is the one mediating the effect of ENSO on local malaria. The anomalies in rain promote more breeding sites for vector population during the El Niño years. Because the events of ENSO are becoming more frequent, it's a matter of question if this is going to affect the frequency of cycle of malaria in the country. Now, when we try to address the long-term trend of malaria, we surprisingly found that the disease transmission has been focal and more prevalent in the southeast of southern Venezuela, where two persistent hotspots of Plasmodium vivax and Plasmodium falciparum have accounted for most of the malaria of the country during the last years. Here, these hotspots are represented by darker colors along a 10-year period. The areas with high risk of malaria in Venezuela are mainly located in the south, in the lowland forest ecoregion, where there has been a significant increment of the deforestation, here represented by red spot by illegal gold mining activities in the last 20 years. When we analyzed the sociodemographic characteristics of the malaria patients in this region, we found that 62% of the surveyed population were minors. On the left, we can see the graph of the Plasmodium vivax cases and the age distribution and gender among these cases. Indeed, the illegal gold mining has increased and expanded in this region since 2000. So based on this observation, we can say that illegal gold mining is one of the main local socioeconomic malaria drivers in southern Venezuela. In the main hotspot of malaria, as deforestation has increased, malaria has increased, as we can see in the graph on the left. So changes in land cover is another environmental factor explaining the long-term increase of malaria risk in Venezuela. Here, when we map the high malaria localities in the mining region, we found that these localities have more breeding sites around compared with low malaria localities. The deforestation and forest fragmentation indeed create large amount of new aquatic habitat for the two main vector species of malaria in this area, Anopheles darlingi and Anopheles albitarsis. Currently, using a deforestation gradient in this area, we are addressing how does forest fragmentation influence vector ecology and increase malaria transmission in southern Venezuela. The illegal gold mining in this area is having a huge impact on different sectors and aspects of the population, but the increase of illegal gold mining in Venezuela is the result of the bad situation in the country. We know that poverty is the main determinant of NTDs, but over the years, we have also seen how sociopolitical conflicts can accelerate economic decline and promote an increase in these NTDs. The increase of vector-borne infection diseases in Venezuela is a remarkable example of it. During the last years, the country has suffered an economic crisis of historical proportions. This situation has precipitated a general collapse of the Venezuelan health system, creating a complex humanitarian crisis with severe social consequences for the country and for the region. According to previous results, the increase of malaria is the result of this crisis. Migration in the country has increased toward the south, where illegal gold mining and malaria are clustered. Economic migrants have reintroduced Plasmodium to previously controlled or new transmission areas, and the population at risk of malaria has increased in the country. At the global level, Venezuela has contributed for most of the regional malaria trends since 2016. In this slide, we can see the incident rate of Plasmodium falciparum during the last year for Colombia, Brazil, Venezuela, and other countries of the region. During 2018, Venezuela reported around 500,000 of cases, with this representing most of the morbidity and mortality by malaria in the Americas. The situation in Venezuela is affecting malaria programs in the bordering countries such as Brazil, as we reported in two recent publications. Most of the malaria detected in the northern of Brazil is coming from Venezuela in an increasing trend during the last years. According to recent analysis and projection made by the World Health Organization, the region of the Americas is far from reaching the elimination goal by 2030 if the situation in Venezuela continues. So there is a need that the Venezuela epidemic be controlled in order to get the region back on track of this agenda. As a final example, Venezuela is the third country, along with Brazil and Peru, reporting recent outbreak of yellow fever in the American region. International and domestic funding are needed for research and public health in Venezuela. There is an urgent need to recover the surveillance and control program in the country. Local risk promoted by illegal gold mining needs to be reduced, and land use change, deforestation in this case, is a challenge to address in the country. National and regional efforts are needed to contain the malaria spread within the country and across the region. Monitoring the potential emergence of parasite resistance is another urgent matter, and the rise of vector-borne infection disease is occurring in the context of a more complex situation, as is the impact of the COVID pandemic. The results presented here are the product of collaborative work with this colleague, whom I would like to acknowledge.
Thank you so much for the talks, for pre-recording the talks. And now we're open for questions. Now, as Amelia's been posting, you can put them in the Q&A at the bottom of your screen. But I wanted to quickly just pass, first of all, to Professor Alicia, who has a question to start us off. Thanks, Alicia.
Yeah. So many thanks to you, Tamar, to the Royal Society, to the Liverpool School of Tropical Medicine, and to Maria Eugenia for this wonderful opportunity. And I was wondering, Maria Eugenia, you work on three diseases that are all of them vector-borne diseases. And therefore, they have something in common. And I know that you are very prone to work also on the identification of the vectors that are in each of the diseases involved. And do you see an overlap of those vectors in the different areas where these diseases are infecting in Venezuela? This is one of the questions that I would like you to answer because I think it is very important and interesting to address, and especially in relation to the Niño effect that you mentioned. Thank you very much.
Yes, well, hello to all. Thanks for attending today to the webinar. And thanks, Alicia, for your question. In the south of Venezuela, we have onchocerciasis and malaria, but they don't overlap in terms of intensity. Indeed, there is a kind of opposite gradient. As long as malaria increase, the onchocerciasis decrease. So, but for example, the onchocerciasis elimination program is a program that is running so many years ago, and because received funding from external international organizations, is also attending the malaria program in the region. So in that case, both diseases are related in terms of control. That is your question. But in terms of climate influences of onchocerciasis, well, we don't have studies about that. I know that there are some studies made in Africa with my colleague Maria Gloria Bazañez, but we don't have that here in Venezuela. We have seen any pattern related to the climate variation. So I don't know if this answers your question.
Yes, thank you very much. Yeah, thanks a lot. Yeah,
thank you so much. And we have a few more questions coming in as the Q&A. So I don't know, Dr. Maria Eugenia, if you can see those. I'm going to first come to Samuel's questions. I think it's a really great one for the context for this webinar. So he just wants to hear a bit more about how deforestation, land change causes an increase in malaria. Could you say a bit more to explain that, please, for us?
Yes, let me read the question. Yes, this is a good question. We are now trying to understand the mechanism involved in that, but we have observed that after the deforestation of the miners, they produce a large water ponds that they are left after the activities of extraction of the gold. And these ponds are colonized by the main breeding site, the main vector in the area. But we are interested in knowing what are other life has history traits that are promoted by the fragmentation of the vegetation to increase the adult population of mosquitoes and the increase of the contact between the human and the mosquitoes. So this is an answer for your question.
Lovely, thank you. And linked to that, I don't know if you can see Timothy's question there at the top for me. So carrying on, he's asking about the sensitization of miners, illegal miners, and how open they are to that, given that there might be a contradiction there.
Well, these are illegal activities. So, and unfortunately, they are probably promoted by the government. So But yes, they have to be involved in the prevention, and the local program of malaria uses to work with them in terms of giving the bed nets and the drug anti-malarial drugs. So, but we need to involve more the minors in the local programs, because it's the only way to reach them, because they are very mobile in the area. They are very deep in the forest. So.
Okay, thank you very much. And then just moving on, so we've got a couple of questions from, I think that's Salum. What research areas should be focused on to disrupt the effect of long-term periodic disasters linked to malaria transmission?
So repeat again.
So this is Salum. I think his or her question is at the top of the list. What research areas should be focused on to disrupt the effects of long-term periodic disasters to malaria transmission?
In the south of Venezuela. Yes, well, the landscape ecology and the landscape epidemiology are they are very important to trying to understand the impact of the deforestation on the increase of malaria, of course, because the deforestation has a huge impact on other aspect of the biodiversity and the emergence, probably the emergence of other pathogens from the forest. So I think that this is a very important line of research that we are trying to follow. No? Yes.
And a follow-up to that, if I may, how easy is it to get funding for that area of work? And I ask that because I don't see so much coming through our journals. I don't know if that's because, you know, we're not the target journals, but is it easy to get funding and researchers that are interested in those areas of work?
Well, it's not so easy to get funding because Venezuela is in one way is considered a high income country, which is not anymore. And because of the bad situation of the last years, and there are few researchers in the country now trying to work on that. So it's not so easy, but we are trying to get funds to increase the research on this area currently. Yes.
Okay, just an idea, we should pick up that question again when we make a call out for our early career grants next year. Maybe we can try and encourage some early career researchers to think about some studies in this area. All right, so I'm going to move on. There are lots of questions. I want to make sure we get to everyone's. Yeah, Jakuba, just to say, I'll reply to you. I'll type the response to you about the presentation. So we have an anonymous attendee question. This is at the top of the list now. In areas where onco has been eradicated, they were asking about change in the ecology of other animals that might have been observed, since obviously sometimes we get this state where eradicating one organism can alter the position for others. So is there anything to say on that point?
No, I don't have to say, I don't have answer for that because we haven't studied that. No. Sorry.
Okay. Oh, no problem. All right, so then we've got the question from M. Presley. So for both onco and malaria, the at-risk populations are groups considered difficult to access, so indigenous populations and so on. Therefore, do you feel that the estimates of burden of disease are affected? Could they be underreported?
Yes, which one is the question?
N. Presley. NP, the initials.
Ah, okay. Let me just read it.
Sure.
Yes. I mean, in terms of the onchocerciasis, no, I can tell you no, because the onco program is dedicated to estimate the real burden of the disease, even searching for new communities in the jungle. But in terms of malaria, for sure. First, because of Plasmodium vivax is the main parasite causing malaria in Venezuela, and there are a lot of not asymptomatic carrier of malaria, of the plasmodium. So for sure, malaria is underestimated.
Okay, brilliant. So moving on then, we have, I'm just going to go to Adriana's question, if that's okay, and I'll come back up. So she's asking, what's the control coverage like in areas affected by onco and malaria in southern Venezuela?
Sorry, I missed your last question. My
sorry.
connection. Okay.
Are you back?
Yes, I am back.
Lovely. So this is from Adriana. It's the question is what's the control coverage like in areas affected by onco and malaria in southern Venezuela?
Control coverage of onchocerciasis is we have been running the program since 2001, and since 2016 the coverage of the population in terms of the administration of ivermectin is more than 80% of the population. This has been the coverage of the administration of the ivermectin since then. In terms of malaria, I don't have that figure. Sorry, Adriana.
Thank you. All right, so we've got a few questions left. I wanted to we were talking about data a little while ago. So I wanted to come to a question from Bueno. So this is at the bottom of my list of questions. I don't know if they're in the same order for everyone. And it's about incidence of malaria. So talking about in Angola, the last two reports show that incidence of malaria that were decreased is inverting and have become very high. And where the incidence was high have become low. And they're asking what could be the cause of that? Is there any insight you could bring from your work?
Well, I don't have a good question, Manuel, but I don't have answer for that because I don't know exactly the situation in Angola, but I feel open to, if you want to write to me and we can discuss.
Wonderful, thank you. All right, so a couple more left. I just wanted to go to Emmanuel's question first because this is really interesting, and a lot of what we try and do as a society is to understand links and connections we can make. So the question is, it'd be interesting to marry the work that you are doing in these areas with other regions similar to Venezuela. What efforts have you been able to make to achieve this, perhaps? And the example is DR Congo. So are there examples of that and other ways we can help with that?
Yes, this is a very interesting question. In terms of onchocerciasis, we have, the Onchocerciasis Elimination Program of the Americas has been working very close with the Africa Elimination Program. So in that way, we are connected, and indeed, some of the message of the America has been passed to the African Elimination Program. But in terms of malaria, we need to do that. I am very open to join and efforts and learning from both regions in terms of the elimination, the control and elimination of malaria. In South America, we have we have high challenges to eliminate the malaria because of plasmodium vivax, because of most of the mosquitoes are not strictly anthropophilic, and they bite in not necessarily in the time when the people are sleeping. So I am open for that.
That's great news. We can maybe help with that as well, Dr. Maria Eugenia. So we have many of our members working on malaria, many of our partners. After the talk today, we can possibly post something perhaps in the newsletter as a blog. And if we can I can talk to you about specific questions or collaborations that you might be interested in within control prevention malaria. We can then see if our members might be able to start some collaborative discussions with you, if that's helpful.
Yeah, thank you, Tamer.
No problem. So we're left with two questions. These are second questions from, so first of all, back to Timothy. So asking, in the areas of disease overlap between onco-malaria, could there be a host pathogen interaction between co-infected individuals responsible for those opposite trends?
Probably is an interesting aspect, but the opposite trend is because of the ecology of both diseases. They are different. Remember the higher pandemic areas are localized in highlands areas where most of the vector of Onchocerciasis are dominant, but not the mosquitoes, because mosquitoes used to breed in lowlands areas, in wetlands. They have different ecologies. So I think that this is the main reason, of the opposite gradient.
Okay, thank you. And then we've probably got a chance for 2 more questions. So the first one, this is about some Bueno, asking, this is way above my head, if the Simulus vector has preference of color, as the tsetse fly does, have a preference for the blue color. This is, yeah, I don't understand this question at all, but I'm sure you do.
Well, probably dark colors, yes, but no blue color. I don't know, but yeah, for sure. I mean, but it depends of the person, because there are another chemical stimulus that uses the female to localize the human resources, the blood. So darker colors are better than not dark colors. Yes, for sure.
Okay, and we have 2 more left, so we'll try and get through these very, very speedily. So Patrick's first. So the question is, like malaria, regions that are closer to rainforest are mostly affected by malaria, and asking if the southern Venezuela vegetation is more densely rainforest than the northern part, which might account for that.
Yes. No, let me read again. Yes, the ecology of the malaria in the south of Venezuela is different to the ecology of malaria in the north of Venezuela, more associated to wetlands and another vector species. So we have different landscape ecology of malaria within the country.
Wonderful. And then Samuel's question is about the link between malaria and anemia. So asking, did you look at the severities of malaria with respect to levels of anemia? I haven't heard that before. That's interesting.
Yes, it's interesting, but I probably some other colleagues, but I am not from that. No, I don't have answer for that question. But it's an interesting one. Yes.
It is, isn't it? Yeah, maybe that's something we could try and close the gap on. Okay, so when I was saying thank you, there's one question from Adriana. We can be quick on this one, perhaps. This is asking about, since there is within and between country migration linked to mining, how do we target economic migrant populations for malaria control? Another tough one.
Wow, Adriana, this is a very interesting question, and I don't have answer for that. I don't. Yes, probably the increase of malaria in the country for sure is related to the economic crisis, and if the economic crisis is solved, for sure there is no need to go to the south to do mining. So in that way, that could be a solution for the problem. No? Yes.
Okay, thank you, everyone. Thank you for your questions.
Yes,
huge thank you.
Can I have all the questions? I mean, could you?
I think we can. Amelia might have to help us. I'm sure they're kept somewhere, so I'm sure we can.
I will be happy to have them. Yes.
All right. Thank you so much. We'll provide the presentation link afterwards. And I just wanted to say a really big thank you to all of you for attending, but especially to Dr. Maria Eugenia and to Professor Alicia for providing this wonderful talk to us. I know that everyone found it very interesting, and we will make it available afterwards for those that weren't able to make it today. Alicia, you have a question or a point? Sure.
No, I do not have a question. I only want to really thank you I mean the Royal Society and the Liverpool School of Tropical Medicine, because this is one of the best ways to tell to the world what we are having in Venezuela. And through the deep work that in this case, Maria Eugenia is doing. So really many thanks. And yeah, we will try to continue. Thank you very much.
Thank you so much. And I know I speak for LSTM as well when I say how pleased we were with this award and to have the chance to showcase your work, Dr. Maria Eugenia. As I mentioned, we can carry on, and I'm sure LSTM will as well, to see if there are ways that we can help provide new collaborations. Anything we can do, we're happy to. So we'll close the event for now. Thank you everyone for joining. Do look out for the medals and awards are open right now for nominations. So please think about other deserving people that you know that we need to recognize. There are lots of other medals and awards available to celebrate success. But for now, congratulations to Dr. Maria Eugenia, and thank you so much, Alicia, for nominating her. Thank you everyone, and see you again soon. Bye-bye.
Thank you. Bye-bye.